Hi, this is Andrea Hendricks, and I want to talk to you about some problems from section 4.3 homework in my math lab. So let's take a look at this first problem. To determine the solution set of the following inequality from the given graph, and it is x minus 1 over x plus 6 is less than 3. Well, if you go by the way the textbook approaches this problem, what you would have to do is say that x minus 1 over x plus 6 minus 3 is less than 0. That is, they set everything opposite from 0 and then combine all of this. You don't have to go through the combining part just to use the graph. The main thing is understanding is that this graph is what's expressed here, and we want to find where that is less than 0. And remember, the key part of that is where that is below the x-axis. So where is the graph below the x-axis? It's below it here and also here, right? So where does that occur? Well, we know that 0, we're told the x-intercept is negative 9.5, 0, and the vertical asymptote is at negative 6. So where is it less than 0? Well, that's to the left of negative 9.5 and to the right of negative 6. So that would be C. Use the graph to give the solution set of f of x equals 0, f of x is less than 0, and f of x is greater than 0. So again, just using the graph. Where is it equal to 0? Well, that's the same thing as the x-intercept, which that is at the origin, so it's equal to 0 at x equals 0. Where is it less than 0? Well, less than 0 is where the graph is below the axis, right here and here. We have to understand that there are two vertical asymptotes. There's an asymptote at x is equal to 1, or negative 1 rather, and also at x is equal to 1. So it is below the axis from negative 1 to 0, and also to the right of 1, from 1 to infinity. And then part C, where is it greater than 0? Well, that happens here, right, and also here. So that is to the left of negative 1, so that would be from negative infinity to negative 1, union, and then between 0 and 1, 0 to 1. So what does that correspond to? I think that one would be, yeah, B. Solve these equations and inequalities analytically. To solve x minus 4 over x plus 5 equals 0, and then x minus 4 over x plus 5 is less than or equal to 0 analytically. And so what we would have here, to solve it, the equation, we're setting x minus 4 over x plus 5 equal to 0, and we can cross multiply to just get x minus 4 is equal to 0, right? So our solution to the equation is just simply 4. Now, to find the solution to the inequality, you can do this by first finding where, let me call this part A and then part B. We're trying to find what makes it equal to 0 and what makes it undefined. Those are going to be the numbers that we come up on our number line. So we know it's equal to 0 at x is equal to 4. Where is it undefined? That's where the denominator is equal to 0, and that is at x equals negative 5. So when we look at our number line, we're going to have partitions formed between the negative 5 and the 4. So if we talk about different regions, we can then test. So out of region A, we can test a number that's less than negative 5, say negative 6. So we would have as negative 6 minus 4 over negative 6 plus 5. Is that less than or equal to 0? Well, that would be what? Negative 10 over negative 1, which is 10, which is not less than or equal to 0. Out of region B, we need a number between negative 5 and 4, so we can choose 0. Is 0 minus 4 over 0 plus 5 less than or equal to 0? Yes, because that would be, excuse me, negative 4/5, which is less than or equal to 0. And then out of region C, we need a number to the right of 4, so maybe we choose 5. So it's 5 minus 4 over 5 plus 5 less than or equal to 0. No, that would be 1 over 10, which is not less than or equal to 0. So the only region that satisfies that is region B, right? So we would have between the negative 5 and the 4. Now you have to be very careful here because we're allowed to include where it's equal to 0. But keep in mind we will never include where the denominator is equal to 0. So where the denominator is equal to 0, you're always going to have a parentheses, which at negative 5. But at the 4, that equals 0 there, so we're going to have a bracket. So our solution would be from negative 5, 4 with a bracket. Now the other problem is to say where is the solution greater than or equal to 0? Well, greater than or equal to 0 is going to be where it was false for less than or equal to 0, right? So that is going to be at so we know that region A and region C would make that part true. Again, we can never include the endpoint that makes it undefined. We can include the endpoint that makes it equal to 0. So in that case, this would be from negative infinity to negative 5 with the parentheses, union bracket 4 to infinity. Now we want to solve this equation and inequality analytically. And it says to draw a graph. I didn't do that on the last problem, but you could put those into the calculator, and I'll show you that on the calculator video. So for part A, if I want to find out where that equation is solved, I can cross multiply to get 6x minus 18 is equal to 3x minus 12. So if we subtract 3x, we would get 3x. If we add 18 to negative 12, we get 6. So our solution is at 2. Now to solve the inequality for part B here, we need to think about what are the solutions to the equation, associated equation, and where is it undefined. So the solutions to the equation come from our answer to part A at x equals 2. It's undefined where the denominator is equal to 0, and that would be at 4 and at 3. So if we then put those numbers on the number line, we have a 2, 3, and 4. So what we would have to do is test in each of those regions. So if we test x equals 0, where are we testing again back in the original problem, is 6 over 0 minus 4 less than or equal to 3 over 0 minus 3. So that would be what? Negative 6/4. Is that less than or equal to 3 over negative 3, which is negative 1? So that's negative 3/2. Is that less than or equal to negative 1? Yes, that would be true. Now in region B, we're going to have to choose something. Let me see, this is A, B, C. Actually, we have D. Okay. Region B, we need something between the 2 and the 3, so maybe 2.5. So it's 6 over 2.5 minus 4 less than or equal to 3 over 2.5 minus 3. So what do we get for that one? I think that would be false there. Let's see about this. That would be 6 over negative 1.5, which is really 60 over negative 15. And that's 3 over negative 0.5, which is really, what, 30 over negative 5. So that's negative 4 is less than or equal to negative 6, which is false. Out of region C, we need something between the 3 and the 4, so maybe we choose 3.5. So we have 6 over 3.5 minus 4. Is that less than or equal to 3 over 3.5 minus 3? Well, the thing to note here is that this expression on the left is negative, right? That would be 6 divided by negative 0.5. This is 3 over 0.5, which is positive. So negative is always less than a positive, so that is true. In part D, we need something larger than 4, so maybe we choose 5. So a 6 over 5 minus 4 less than or equal to 3 over 4 minus 3. So that's 6 over 1, which is 6. Is that less than 3? No, that is false. So the only regions that satisfied that were A and C. Now, what about the endpoints do we need? Since we're allowed to include where it's equal to 0, we're going to have a bracket only with the x equals 2. We're going to have a parentheses on the 3 and the 4 because they are where the value of the denominator is 0. So it would be from negative infinity to 2, union, parentheses, 3 to 4. Now, part C is everywhere else. Right now it's greater than or equal instead of less than or equal to, so that would be in regions B and D. So for that we would have a bracket at 2 to 3 with a parentheses, union, parentheses 4 to infinity. Now if we want to solve this inequality, x minus 3 over x plus 2, x minus 3 times x plus 2 all over x minus 4 is less than 0. So what we have to first find is where is that equal to 0. So it's equal to 0 where x minus 3 times x plus 2 is equal to 0, right? If we cross multiply, think about that being over 1, we would get then that x is equal to 3 or x is equal to negative 2. And then where is it undefined? That's where the denominator is equal to 0, which is that x is equal to 4. So to find the solution, we can draw the number line, put these numbers from least to largest, right? Negative 2, 3, 4. And then test points out of each region, A, B, C, and D. So out of region A, we can test what? Yeah, something to the left of negative 2, so let's test negative 3. So we would have as negative 3 minus 3 times negative 3 plus 2 all over negative 3 minus 4 is that less than 0. So what is this? Negative 6 times negative 1 all over negative 7. Is that less than 0? Yeah, that would be positive 6 over negative 7, which is negative 6/7, which is less than 0. Out of region B, we choose something between the negative 2 and the 3, so maybe we choose 0. So is 0 minus 3 times 0 plus 2 all over 0 minus 4, is that less than 0? So we have what? Negative 3 times 2 over negative 4. But that is negative 6 over negative 4, which is a positive, so that would be false. In region C, we need to choose something between the 3 and the 4, so unfortunately we have to use a decimal. So if we use 3.5, we would have as 3.5 minus 3 times 3.5 plus 2 divided by 3.5 minus 4. Is that less than 0? Well, this would be a positive, right? 0.5 times 5.5. This would be a negative 0.5. So positive times a positive is positive, divided by a negative would be negative, so this would be true. And then lastly, out of region D, we need to choose something larger than 4, so maybe we choose 5. So is 5 minus 3 times 5 plus 2 over 5 minus 4, is that less than 0? So what is that? 2 times 7 is 14, divided by 1 is 14, which is not less than 0. So the only thing that satisfied it was region A and region C. Now what about the endpoints? Well, here this is strictly less than 0, which means we can't include where it's equal to 0, and we never can include where it's undefined. So here we're actually going to have all parentheses. So our solution would be D. Now to solve this inequality and state and graph the solution set, 1 over x plus 2 is greater than 1 over x minus 5, we first have to find where it's equal to each other. So if you cross multiply there, you would just simply get that x minus 5 is equal to x plus 2. If you subtract x from both sides, those are eliminated, so you're left with a false statement, which means that there's no solution to that equation. So the solution to the equation doesn't exist, but we do have places where the expressions are undefined. It's undefined where x plus 2 is equal to 0, which is at negative 2, and where x minus 5 is equal to 0, which is at 5. So on our number line, we're only going to put on the numbers negative 2 and 5. So out of regions A, B, and C, we're going to choose those numbers to test. So let's say out of region A, let's choose maybe negative 3, write something to the left of negative 2. So we would have is 1 over negative 3 plus 2 greater than 1 over negative 3 minus 5. So we have 1 over negative 1, which is negative 1. Is that greater than 1 over negative 8? Is negative 1 greater than negative 1/8? No, that is false, right? Number out of region B is 0. So we're saying is 1 over 0 plus 2 greater than 1 over 0 minus 5. So this is 1/2. Is that greater than negative 1/5? Yes, that is true. And our last number to test, something from region C, so perhaps 6. So we're asking is 1 over 6 plus 2 greater than 1 over 6 minus 5. So that's 1/8. Is that greater than 1 over 1, which is 1? And of course that's not true, right? 1/8 is not greater than 1. So the only solution is region B. And what about our endpoints? Since it's strictly greater than 0, we wouldn't include any of the endpoints anyway, so it's going to be all parentheses. So our solution in interval notation is from negative 2 to 5 with parentheses, and the graph is part D. Now a couple word problems that we're going to work. If the average number of vehicles admitted through the gate of an amusement park per minute is equal to x, then the average waiting time in minutes for each vehicle at the gate can be computed by y is equal to x minus 5 over x squared minus 10x, where x is only defined when it's greater than 10. Estimate the admittance rate x that results in an average wait time of 12 seconds. I have to be honest with you. I made the critical mistake when I worked this problem to begin with, because I didn't pay attention to the units. The average wait time is 12 seconds, but understand the average waiting time is given in minutes. So what we have to do is we have to convert 12 seconds to minutes. Well, remember that there are 60 seconds in a minute, so we have to divide by 60 to get that this is the same thing as 1/5 of a minute. Now, the average waiting time is what y represents, so what we're going to do is set y equal to the 1/5 and then solve the equation that results. So if we cross multiply, we get x squared minus 10x is equal to 5 times x minus 5, which is 5x minus 25. So this is a quadratic equation we have to set to 0. So we would get x squared minus 15x plus 25 is equal to 0. So if we plug into the quadratic formula, we would have x is equal to the opposite of b, so that would be the opposite of negative 15, or just 15, plus or minus the square root of b squared minus 4 times A times C all over 2 times A, or just 2. So what do we get here? 15 plus or minus the square root of negative 15 squared is 225, minus 4 times 1 times 25 is 100, all over 2. So we get x is equal to 15 plus or minus the square root of 125 all over 2. Now on the calculator, you could input that if you wanted. We have in parentheses 15 plus the square root of 125, close the radical, close the numerator, divided by 2 is 13.09. Our other answer, if we do second enter and change the plus to a minus, we get our other value of 1.91. So we have 13.09 and 1.91. But understand x is only defined when it's greater than 10, so we can't use the 1.91. So the admittance should be about, said round to the nearest hundredth, 13.09 vehicles per minute. Okay, and the last problem, find possible dimensions for a closed box with volume 384 cubic inches. The surface area is 400 square inches, and the length is twice the width. So what we have to do here is kind of understand all the variables that are going on to get something in terms of just one variable. So one thing we're told right away is that the length is going to be twice the width, right? The other thing we know is that the volume is 384 cubic inches. Well, volume is what? Length times width times height is equal to 384. So we can get that in terms of two variables, right? We know that 2w is the length times the width times the height is 384. So we would have 2w squared h is equal to 384. So we could actually solve for h to get 384 over 2w squared is h. And if we divide everything by 2, what is that? 384 divided by 2 is 192. I think I worked that out. Yeah, 192 over w squared. Now, the other thing you may not remember, surface area, is if you add up the areas on the whole surface of a box. If you have a closed box, to find the area of each piece, it's just a rectangle, so you would have to do length times width, or width times height, or length times height, depending on where it is. But actually, the surface area is defined to be 2 times the length times the width. That's because the length times the width is a bottom piece, and there's a parallel piece at the top, right? Plus 2 times WH. The width times the height is this face right here, and there's a parallel side over there. And then plus 2 times the length times the height. Okay, the length times the height would be the side piece. So if you add up all the areas of every surface, that's called the surface area. We know that's equal to 400. Well, we can't have all three variables here, so we're going to convert everything in terms of W. Right, so we know that the length is 2 times W. Oops, yeah, that's right. Plus 2 times W times the height we just found is 192 over W squared. Plus 2 times L, but L is 2W, times the height, which is 192 over W squared. And we can clean this up. So we get 400 is equal to, what is that, 4W squared, plus, notice that one of the W's is common, so that will divide out. 192 times 2 is going to be our 384 over W. And then plus, we can clean the last term up. The W's will divide out. 4 times 192 It's going to be 768 over W. So we need to solve this equation. Well, we can do that if we set it to 0, right? So we could have 0 is equal to 4W squared, and actually combine some like terms here, right? 384 over W plus 768 over W combines to be 1152 over W, right, because they're the same denominator, and then minus 400. So we can solve this graphically. If we input this into y1 and then find the zeros, we get the solution to our problem. So let's do this here. In y1, I've actually already entered it. 4x squared plus 1152 divided by x minus 400, and we graph. Now I had to change the window, and just so you can see the window settings, from negative 10 to 10, and my y-min was negative 70 to 200. And I'll write that down for you in just a minute. So we have two solutions. The way we find those, remember, we can do second, trace, and 0. Our left bound, actually we don't have, it's undefined at 0, so we can't use that. But we have to come down. Here we go. A left bound, enter. A right bound. Remember, you want to be on the left and right side of that 0, and then our guess. So one solution is 3.21. To get our other solution, we can press second and trace and 0. And let's do a left bound of this one. Okay. And a right bound. And then a guess. Okay, so 8 is the other solution. So it was at 3.21. And W is equal to 8. Okay. So it says find the possible dimensions. The width of the box can be either 3.21 inches or 8 inches. And that's a solution. So that window that I used, the x-min and x-max were from negative 10 to 10. And my y-min was, what, negative 70, I think I said. My y-max was 200. And I did a y-scale of 20. But you would see, if you did it in the standard window, you would see that it crosses the axis at 8 and 3.21. So I just had to clean up. I looked at my table to figure out what the high and low points were around those particular values. Okay? So if you have any questions, don't hesitate to contact me. Thanks.